Good morning, Tehmina Khan is here in TKMaths is Fun. This is video number 3 on integration, and in this video we will cover integration of trigonometric function. So before we begin, you can see in the bottom my website address and my blog address. Do visit it, you will find it very useful, and there are many free videos available to increase your learning. So let's begin with the integration of trigonometric function. There are few basic forms. Three are these: simple integration of cos x, sin x, and sec square x, which will be given to you in MF19. So derivative of it is not part of your syllabus, so you need to learn it as it is, that when you integrate cos x, you get sin x, and you know why we write plus c? It is arbitrary constant. Integration of sin x is minus cos x. Integration of sec square x is tan x, right? Like in differentiation, sin x differentiation is cos x, differentiation of cos x is minus sin x, and differentiation of tan x is sec square x. So this is the simple form. Now what if it is given in this form? Because this is also part of your syllabus, it is mentioned over there. So how do you integrate it? We have seen that the integration of cos is sine, right? So integration of cos, now this is your angle, it will remain sine ax plus b divided by coefficient of x. So you have a here, so divided by a. Similarly, integration of sine is minus cos. We have seen from here. So whatever the angle is here will remain here, divided by the coefficient of a. So integration of sine is minus cos, angle divided by a, and plus c, because it is indefinite integral. Similarly, for integration of sec square ax plus b, it will be tan ax plus b divided by a, the coefficient of x. Again, you will have only this form in your syllabus, not in any other form, this linear function. So let's see the example. How do we apply it? This is the definite integral, and question is asking to find the exact value of it. So there are two terms, sine 2x and cos 4x. So integration of sine will be what? Do you remember? Integration of sine is minus cos. So it will be minus cos 2x divided by 2. Agreed? You can see integration of sine is cos 2x divided by 2. And why this minus? Because integration of sine is minus cos. Similarly, integration of cos is sine. Simple. So that's why this sine, minus sign will remain here as it is. And divided by coefficient of x, which is 4. After that, you will apply limit. Make sure the mode of the calculator is in radian, right? This is the common mistakes students usually make. So make sure whenever you are doing integration and differentiation of trigonometric function, the calculator is in radian mode. Now in place of x, you will write pi over 3 here and then minus 0 here. Usually students think that when it is 0, it will be 0. But remember, cos 0 is not 0. Cos 0 is 1. So be very careful about this. Actually, students are used to polynomial functions, and they think whenever x may you replace by 0, the answer is 0. It is not. So in place of x, pi over 3 is applied. Then in place of x here, pi over 3. After that, minus with the application of 0 here. So upper limit minus lower limit. And then simplification, use the calculator, find out the values, and then get the answer. So we always give the answer in the simplified form, which is the last possibility. You cannot further simplify from here, right? If you want to put it on pause and you want to do it yourself, that is the best. Okay, now there are some trigonometric integration which are a little difficult or need some special handling in a way that you need to apply identity there. And this particular identity is used a lot in those cases. And what are those cases? When you integrate sine square theta, for example, the questions like this, integrate sine square x or integrate something which has sine square or cos square, then you use this identity. And I will show you the application. I have two examples here. Now, another thing you have to remember is that, see the relationship between the angles. When this is 2a, what do you have here? 1a, 1a. It means the ratio is 2 is to a, 2 is to 1. If I take here cos 4a, and I ask you what this will be equal to in this form, because cos 2a identity is given in 3 different forms. Depends what do you need to use there. So if it is cos 4a and I want to write down this identity, it will be equals to 2 cos square, now 2a minus 1. Because the relationship between this angle and this angle is 2 is to 1. Suppose I have cos 6a, right? So it will become 2 cos square 3a. So you need to use this intelligently. Okay, and we will see in one of the question this application. So when it is 2a, it is 1a. When it is 8a, it is 4a, things like that. So let's solve this question. Integrate sine square x. So like I said, you need to use this identity. Sine square is present in the third form, this form. So here it is written, and I will make sine square x a subject. I'm repeating, I am using this identity, which is cos 2x is equals to 1 minus 2 sine square x. It will be given to you in MF19, all these 3 forms. You only need to understand that where you have to apply it. Okay, so now we are rewriting it, making sine square x a subject. So you will get this form, right? If you are not sure how, so let me show it to you. I'm taking, for example, this whole term to that side. It will become 2 sine square x is equals to 1 minus cos 2x, then sine square x. This 2 will come underneath here in each term, or you can write it separately together. Choice is yours, right? So now sine square x I can replace by this term. See, I have applied here. I have replaced sine square x by this whole term. Now this is a multiplier, so you can take it outside the integral sign. It will not affect the integration. The integration of 1 with respect to x is x, and integration of cos 2x is sine 2x divided by 2, the rule we have just learned. And then you are simply multiplying by half, and plus c because there are no limits. So don't forget to write it, you may lose 1 mark. Okay? Now let's see if it is cos power 4x. Now this is little tricky. Technique is exactly same. Cos power 4x can be written as cos square x too, because if you remember, when we write like this, for example this, it means this thing. Some children misunderstand and they write it like this, which is wrong. This means this. So if it is 4, power 4 here, so it will be square because 2 2s are 4 it will be. Do not think it is x square. You will not apply a square on this. Okay, do not make that mistake. Now we have just seen in the previous question how to make cos square x or sin square x a subject, right? Using this identity. So now we are making cos square a subject. If you want to see here, let me erase this. For example, it is cos 2 theta is equals to 2 cos square theta minus 1. So if I make this a subject, it will be cos 2 theta plus 1 divided by 2. So that's why we have replaced it by it. Now this overall square will be applied on half and will be applied on this also. So it will become 1 over 4. And you know how this becomes this? Remember this algebraic identity? What it becomes? A square plus 2ab plus b square, right? So exactly same identity we are applying here. This is my a, this is my b. So a square plus 2ab plus b square. After that, This is fine. I can integrate it because you see why we are doing all this. Because we have to replace this thing by this. But again, there is cos square another time. So now you have to apply this identity another time. But this time, it is cos square 2x. Yani कि this thing is 2 theta. If this is 2 theta, this will be 4 theta. So now that's why when we manipulate it, so cos square 2x will become cos 4x plus 1 divided by 2. I'm getting all this from here. If I make this a subject, this will go here, it will plus 1 and divided by 2. Exactly same thing. You can do it in the copy, put the video on pause and you will see, you will get it. Now we know that cos square 2x is equal to this. So I can replace this part by this whole thing. This is fine. After that, you simplify. Now we can replace cos 4x by this whole thing. Yes or no? And then after that, you can integrate it easily. So I'm just leaving it here. I want you to complete it now exactly the way I have done here. That once I replace sine square x by the whole identity here, and then I can easily integrate it. So now you replace this cos power 4x by this whole thing, right? And then integrate it. So let's just 1 minute. What the integration of this will be for this term, for example. It will be integration of cos is what? Sine, right? So it will be sine 4x divided by 4. Agreed? What will be the integration of this term? Because integration of cos is sine, so it will be half sine 2x divided by 2. And this will be 3 upon 8x plus c, right? So it's simple. So here is a practice question, past paper question. Show that this thing is equals to this. I'm not completely solving it, giving you the start, and you will try it yourself. Exactly on the basis we have done just before 2 questions, right? So here is the hint. When you are integrating it, and the limits are here 0 to pi by 4, okay, it will be sine 2x divided by 2, and limits you will apply upper limit minus lower limit. Remember, the mode of the calculator should be radian. Then it is saying by using an appropriate trigonometry identity, find it. So what identity comes in your mind? By the way, this is written here. Every time it is not given, a hint is not given to you. Straight away the question will come in this form. So you have to apply limits yourself. Sometimes hint is given, sometimes it is not. So we know that 1 plus tan square x equals to sec square x. I can make tan square x a subject and it will become sec square x minus 1. So now tan square x I can replace by sec square x minus 1, right? So the question is changed now, 3 as it is. This is replaced by identity and the limits are pi by 6 to pi by 3. So what is the integration of sec square x? Tan x. And integration of minus 1 is x. So after that you apply upper limit minus lower limit. Okay, so now here it is, upper limit minus lower limit. I think I solved it completely to help you out. Okay, so then calculation part applied in the calculator and you get the answer. So the best way is that you always put the video on pause and try it yourself, because maths is all about doing it yourself. Only listening does not help you. It cannot help you to retain the concept. So here are 2 questions, 2 more. One I have solved. So 2 more questions. I have taken them from past papers, June of 7 and November of 7. Try it, solving it. I'm sure, inshallah, you will be able to do it because it is exactly what we have done. And you know, past paper question, merge the concepts. So identity you have to prove first. Okay. And because why this is helping you, if you see it is exactly same. Can you notice? So this whole thing can be replaced by this, and you can integrate it very easily. So all the best. Here are the answer of these two questions. So thank you very much for watching this video. In the next video, we will see the integration of a special type, this type, right? So with this I end. Let's you practice these practice questions and then watch the next video.